Welcome back to the deep dive. We're taking all that recent market panic, the jargon, the finger pointing that always happens after a big crisis, and we're turning it into something clear, something usable for you. If you've been anywhere near the digital world lately, the internet's been, well, feeling a bit sick. We all saw that very public, very painful outage hitting AWS's US East 1 region. And suddenly, applications, all over the globe felt that ripple, like our source material put it perfectly. When the cloud sneezes, the internet catches a cold. That really nails it. Now, there's been a huge amount of talk about, are we too reliant on just one big vendor? We're actually going to sidestep that argument today. Our mission, really, is to tackle what feels like a more immediate, maybe more vital question. Are we too reliant on a specific cloud region? Doesn't matter who the provider is. We're sort of taking that Churchill advice, right? Don't let a good crisis go to waste. Let's use this for some serious thinking about architecture.
Yeah, that's absolutely the right way to frame it. We really need to shift away from, who's to blame. Because look, every major provider, AWS, Azure, GCP, they will have failures. It's inevitable. This deep dive, it's really about that core debate in modern engineering resilience. Do you go multi-cloud for the ultimate safety net, or is multi-region actually the smarter, more pragmatic path for keeping things running smoothly?
Okay, yeah, let's unpack that then. Why does one single region, US East 1, specifically cause such a massive global ripple effect? It feels really counterintuitive, given the whole promise of a distributed internet.
Well, it's more than just scale. It's got this kind of historical weight, this infrastructural gravity, if you will. US East 1 was the first big region AWS launched, so historically it often ended up hosting the global control plane for a lot of really essential AWS services. Think about it like this. Even if your main application is humming along nicely in, say, Frankfurt or maybe Sydney, critical things like global DNS settings, identity management, that's IAM, or even just the billing and metering, those often still need to talk back to the control plane bits sitting in US East 1 to, work properly or just authenticate. So if that one region goes down, well, even your services hosted elsewhere can suddenly become unmanageable. Or they can't verify who's logging in, and boom, you get this cascading failure that spreads globally.
Wow. Okay, so even if I've done my homework, spread my workload across different AZs, maybe even different continents, if that core authentication piece, or like you said, the central metadata service, if that lives in that one historical region and it hiccups, everything else can just grind to a halt. So the fundamental risk is crystal clear, putting all your critical eggs in one regional basket.
Exactly right. That's the core vulnerability.
Okay, so that leads us directly into that classic conversation that happens after every outage, hedging your bets. And specifically, people start talking multi-cloud. I mean, on paper, it looks like the perfect insurance policy, doesn't it? Spread everything across different companies, different vendors, and you're safe if one of them has a really bad day. But let's be precise. What specific risk, what distinct risk are you actually trying to mitigate when you choose a multi-region approach versus a full multi-cloud setup?
Yeah, we absolutely need to be precise here. It's about understanding the level of isolation you're really buying and what you're paying for it. So with a multi-region strategy, that means using multiple geographic regions, but within the same cloud provider like AWS. You're hedging the risk of a single geographic region failing. That protects you from, say, a regional control plane meltdown like we saw, or maybe a big natural disaster hitting that one area. Now, with multi-cloud, where you're actively using different vendors, maybe AWS and Azure and GCP together, you're hedging against a much bigger, arguably much rarer risk, an entire vendor failing completely. Or maybe more realistically, you're protecting yourself against vendor lock-in strategically for pricing power or future flexibility.
Right. And the sources we looked at are really clear on this point. The multi-cloud option comes with a serious price tag. It's way more complex, way more expensive than just using multiple regions within your main provider. The analysis seems to suggest that for most organizations, the sweet spot, the pragmatic choice, is really sticking with multi-region inside one cloud.
That makes sense because resilience, it's a bit like security. It's often a game of diminishing returns. Going multi-region within one cloud, that probably gets you, say, 80, maybe 90% of the total resilience benefit you could possibly achieve. But it does it at a fraction of the cost and, crucially, the complexity of trying to build and manage a full multi-cloud system. You shield yourself from those regional disasters without needing to duplicate every single tool, every process, every skill set across completely different platforms.
Okay, but hang on. If we're really talking about risk here, isn't vendor lock-in itself potentially a huge like catastrophic long-term business risk, not just a technical blip, but something strategic. Doesn't multi-cloud, even though it's expensive and complex, maybe become necessary insurance against that ultimate nightmare scenario? Like your main vendor fails entirely or jacks up prices astronomically?
That's definitely the right question to be asking. And it's exactly why multi-cloud does remain relevant, especially for certain sectors. Think highly regulated industries, finance, healthcare maybe, or just massive global enterprises. For them, the potential cost of vendor failure or lock-in might genuinely outweigh the operational pain. But, and this is a big but for most businesses, the sheer technical difficulty, the day-to-day burden of running truly separate, truly functional duplicates across different vendors, that operational complexity often ends up being a bigger, more immediate risk than the vendor failure scenario it's supposed to prevent.
Okay, this is where it gets really, really interesting for me. We keep saying multi-cloud is expensive, complex, but what exactly makes up that complexity tax everyone talks about? Can you break down some of those big hidden costs that just pop up when you try to actually bridge, say, AWS and Azure and GCP?
Right, the complexity tax. It really comes down to the fact that each of these major cloud platforms, they just have a fundamentally different DNA, a different philosophy baked in. They're not just slightly different menus for the same underlying thing. They're built differently from the ground up. Think about their networking models, totally different. Their IAM systems for handling identity and permissions unique to each, storage services, APIs, all distinct. So to get true portability, true failover capability between them, you're essentially forced to duplicate your architectures, your deployment tooling, your monitoring, and critically, your team skills. You need people who deeply understand each platform's quirks, all that extra operational overhead. It doesn't just cost money. It often introduces brand new ways for things to break, new points of failure that you created yourself. So yeah, it can feel less like buying sensible insurance and more like, I don't know, building 3 completely separate custom cars that somehow all have to share the same unreliable engine.
Wow, yeah, just describing it sounds exhausting. So the pragmatic advice then, it seems, is like walk before you run. Solve the basic problems first.
Precisely. That's the key takeaway here. If you're even thinking about going multi-cloud, you first have to get really, really good at solving all the fundamental resilience challenges that a single vendor, multi-region setup already demands. Things like data replication, state management, automated failover. Those are hard problems within one cloud.
Yeah.
If you can't make your application truly resilient across, say, 2 AWS regions, you've got absolutely no chance of making it resilient across AWS and Azure. So for most folks, strengthening resilience within your primary platform, that's not just the starting line, it's often the most impactful thing you can do.
Okay, that makes a lot of sense. And it naturally shifts our focus, doesn't it? Away from just debating vendors and more towards looking inward at our own architecture. You know, a lot of teams, they prioritize shipping new features, the flashy stuff. But things like availability, reliability, what we call non-functional requirements, they often get less attention. They're kind of invisible until, bam, a crisis hits.
Exactly. They are those crucial quality attributes. They define how well the system actually performs, especially under stress or when parts of it fail. And the fundamental job, the mandate really, for architects is designing systems that can degrade gracefully. They shouldn't just fall over catastrophically when something goes wrong. The architecture needs to be smart enough, robust enough to ensure that the core essential functionality still works, even if some secondary non-essential dependency fails.
Okay, so graceful degradation. Is that like when my banking app maybe can't show the livestock ticker because that server is down, but it can still reliably show me my account balance and let me transfer money?
That's a perfect example, yes. Or maybe your fancy AI-powered product recommendation engine fails. Graceful degradation means the website doesn't just crash or throw up a big, ugly error message. Instead, it maybe defaults to showing, I don't know, the 5 best-selling items in that category. The user can still browse, they can still buy. The core business process survives, even if the experience is temporarily a bit less personalized or feature-rich. The key is, it doesn't just break completely. And this brings us to that core economic question, really. You have to weigh things up. At what point does the potential cost of an outage, and that cost could be direct financial loss, could be reputational damage, maybe even regulatory fines, when does that potential cost clearly outweigh the complexity tax of building and maintaining these more resilient duplicate architectures designed for graceful recovery? Resilience, at the end of the day, it should be viewed as outcome you architect for. It's not just another line item, another spend category you try to minimize. It's a capability you build.
Okay, that's a powerful way to put it. So for someone listening right now, maybe reviewing their own systems after this recent outage, what does this all mean practically? Are there tools, frameworks, something concrete to help guide us through this kind of assessment?
Oh, absolutely. And actually, we have a really brilliant guide for exactly this, which is the AWS Well-Architected Framework. Now, it's structured around 6 key pillars, covering things like cost, security, performance. But for this specific discussion, the reliability pillar is bang on target. It's exactly what we're talking about. It gives you clear recommendations. Things like designing your system so they can recover automatically from failure without manual intervention if possible. It pushes you to test those recovery processes regularly, things like chaos engineering, game days, actually practicing failure.
Mm.
And it emphasizes scaling horizontally, building redundancy in so you avoid those dreaded single points of failure. It essentially gives you a structured way to think about failure before it happens, proactively.
Right, so the well-architected framework gives us the philosophy, the principles. If we were to distill that down even further into like immediate, practical, actionable steps, what would you say are maybe the top, say, 4 non-negotiable things that every architect should be looking at or doing today?
Okay, yeah. If I had to boil it down to 4 immediate actions, building on what we've discussed. First, regional redundancy. And be clear about the distinction. You must plan for failure at the entire region level, not just availability zone level. Look, AZs are great, they're essential, they protect you from localized failures like a specific data center losing power or cooling issues within that region. But regional redundancy, planning for failover to a different region, that protects you against those bigger control plane failures we discussed, or massive natural disasters, or large-scale utility outages that could take out the whole region. That's step 1. Second, cross-region replication. This just has to happen for your critical data and your most essential workloads. No excuses. You have to be confident that your key data can survive, even if an entire region just, poof, disappears tomorrow. Third, graceful degradation. Really map out your application's dependencies. Understand what talks to what, and then design it so that if a non-essential service fails, like that recommendation engine, your core application functionality persists. Aim for slowdown, maybe reduced features, but not total shutdown. And finally, number 4, infrastructure as code, IAC. Your recovery process needs to be automated as much as humanly possible. When the worst inevitably happens, the response shouldn't be frantic emails and people scrambling trying to remember how things work. The action should be pushing a button, triggering a well-tested, fully automated redeployment process in your backup region. Recovery via script, not via panic.
Recovery becoming a defined process, not a chaotic panic.
Yeah, that feels like the ultimate measure of whether you've really nailed resilience planning.
It really is. I think the main insight, the big takeaway from all this is that true resilience, it isn't fundamentally about which specific cloud vendor you happen to choose. It's much more about how intentionally, how thoughtfully you architect for failure within whatever environment you've chosen. Resilience is that outcome we talked about, and you achieve it through disciplined, proactive architectural choices, ideally guided by solid frameworks like well-architected.
Okay, so for you, the listener, perhaps the biggest takeaway here is don't wait. You've got to proactively use the frameworks, use the tools available, bake this resilience thinking into your systems long before the next alert fires. Make recovery that well-oiled process, that muscle memory your team executes calmly without hesitation. Exactly. And maybe here's a final thought, something for you to mull over and perhaps explore next in your own context. Remember, resilience isn't really about avoiding problems altogether. That's impossible in complex systems. It's truly about how fast and how gracefully you can recover when those problems inevitably occur. So ask yourself, what specific parts of your own system's recovery process, maybe your runbooks, your failover test results, your data restore procedures, what parts haven't been fully exercised, fully tested since the last crisis that didn't involve your team running around, well, screaming? Find those gaps. Get testing today. Don't wait for the next real fire drill.